Hello everyone. Here I am Pallavi Deshmukh. Once again welcome all of you in today's session. Today's experiment is to determine the percentage of ferrous ammonium sulfate, that is Mohr's salt, by titration with KMnO4. The apparatus which are needed for the experiment is burette, pipette, conical flask, volumetric flask, weighing bottle and funnel. Solution which are required for the experiment is ferrous ammonium sulfate solution, dilute sulfuric acid, potassium permanganate solution and unknown FAS solution. This experiment is an example of volumetric estimation involving an redox reaction, that is oxidation and reduction reaction. Ferrous ammonium sulfate, which is also called Mohr salt, is an reducing agent and acidified KMnO4 being an oxidizing agent which is useful to convert the ferrous ion into the ferric ion, that is Fe dipositive into the Fe tripositive ions. This reaction is very slow at room temperature and therefore carried out at 60 to 70 degrees Celsius. In this reaction, the KMnO4 is converted into MnSO4. The oxidation state of the Mn in the KMnO4 is +7, while the oxidation state of the Mn in MnSO4 is +2. So, the Mn +7 is converted into Mn +2. Similarly, the Fe dipositive ion is converted into the Fe tripositive ion. The ionic form of the reaction is also shown in the slide. The molecular weight of the ferrous ammonium sulfate is 292.14 and the equivalent weight can be calculated by using the formula, that is molecular weight divided by number of electron loss or the gain. And in this reaction there is a change of only one electron, that is Fe dipositive ion is converted into Fe tripositive ion. Therefore the equivalent weight of ferrous ammonium sulfate is equal to its molecular weight, that is 392.14. Now in case of the KMnO4, the Mn7 positive ion is reduced to Mn dipositive ion. So the equivalent weight of KMnO4 is equal to molecular weight divided by number of electron gain, which is 5. So the equivalent weight of KMnO4 is 31.6. Now the procedure. In the first step, we have to prepare 0.1 normal ferrous ammonium sulfate solution. And for that, we have to note down the weight of empty, clean and dry weighing bottle. After that, add an approximately 4 gram of ferrous ammonium sulfate into the empty weighing bottle and note down the reading. Now transfer the substance from the weighing bottle to the 100 ml of volumetric flask with the help of the funnel and note down the weight of weighing bottle after transferring the compound. Now dissolve the FAS into the minimum quantity of the distilled water and make up the volume up to the mark. The next step is the standardization of KMnO4 solution by the known ferrous ammonium sulfate solution. For that, fill the burette with the KMnO4 solution. Now pipette out 10 ml of known ferrous ammonium sulfate solution in a clean conical flask and add equal volume of, that is 10 ml of 5 normal H2SO4 solution. Now run the KMnO4 from the burette slowly and shake the flask. Continue the addition of KMnO4 solution until a light pink color just appears and persist for about 30 seconds. Now note down the volume of KMnO4 required as an endpoint. Repeat the titration till the 3 constant readings are obtained. The next step is the preparation of unknown ferrous ammonium sulfate solution. For that, pipette out 10 ml of the unknown ferrous ammonium sulfate solution into the 100 ml of volumetric flask and add equal volume of, that is 10 ml of 5 normal H2SO4 solution. Shake the contents in the flask and make up the volume up to the mark with the help of the distilled water. This is the unknown ferrous ammonium sulfate solution. This step is for the determination of strength of given unknown ferrous ammonium sulfate solution. For that, pipette out 10 ml of unknown ferrous ammonium sulfate solution into the conical flask and add 10 ml of 5 normal H2SO4 solution. Now run the KMnO4 from the burette slowly and shake the flask. Continue the addition of KMnO4 solution until a light pink color just appear and persist for about 30 seconds. Now note down the volume of KMnO4 required as an endpoint. Repeat the titration till the 3 constant readings are obtained. Now the observations and calculations. Weight of the empty weighing bottle is 17.10 gram. Weight of the weighing bottle plus ferrous ammonium sulfate is 21.60 gram. Weight of the weighing bottle plus remaining ferrous ammonium sulfate after transferring the substance from weighing bottle to the volumetric flask is 17.60 gram. So the exact ferrous ammonium sulfate taken is 4 gram. Mass of the FAS dissolved in 1000 ml of the solution can be calculated, that is W into 10, that is weight of FAS taken into 10, which is 40 gram per liter. This table is for the titration between standard ferrous ammonium sulfate solution with that of the KMnO4. From this table, it is seen that 6.5 ml of the KMnO4 is required for the titration of 10 ml of ferrous ammonium sulfate solution. This table is for the titration between the unknown ferrous ammonium sulfate solution with that of the KMnO4. And it is seen that 3.3 ml of the KMnO4 is required for the titration of 10 ml of unknown FAS solution. Calculations. Mass of the ferrous ammonium sulfate dissolved in 1000 ml of the solution is given by weight of the ferrous ammonium sulfate taken into 10, which is 40 gram per liter. And from that, the normality of the ferrous ammonium sulfate solution can be calculated by using the formula, that is strength upon equivalent weight. So by putting the values, the normality of ferrous ammonium sulfate solution was found to be 0.102 normal. Calculating the normality of FAS solution, the normality of KMnO4 solution can be calculated by using the simple formula N2 is equal to N1 into V1 divided by V2. And by putting all the values, the normality of KMnO4 solution was found to be 0.156 normal. And by putting the value of normality of KMnO4 solution, the normality of unknown ferrous ammonium sulfate solution was calculated, which is found to be 0.0526 normal. By calculating the normality of unknown ferrous ammonium sulfate solution, the strength of the given FAS solution can be calculated by using the simple formula, that is the normality of unknown FAS into its equivalent weight. And by putting the value, the strength of FAS is found to be 20.62 gram per liter. And by the strength of the given FAS solution, the percentage purity of the given FAS solution can be calculated and was found to be 51.56%. The result, percentage purity of the given ferrous ammonium sulfate was found to be 51.56%. Thank you so much.